Good morning, ninth grade honors students. So this week we are going to keep going with our preview of 10th grade math, and we're going to talk about odd and even functions, something we really didn't cover in ninth grade. We should have a little bit more than we did. So a function is even if the graph of f of x is symmetric with respect to the y-axis. So you can think of some graphs that are symmetric with respect to the y-axis, like the absolute value of x, or x squared, or x squared minus 4, or so on and so forth, okay? Those are all considered even functions. Now you may notice that x squared and x to the fourth look very similar in the end behavior, okay? They're both even functions. X to the fourth has this extra little bump in it, okay? X to the sixth may look like this. Actually, this would be centered. Let me put that axis back in the right place, so it would be centered here. Okay, and I'm over exemplifying these bumps here. Okay, when you look at it on a calculator, it's gonna maybe look just like x squared, except that this piece down here, we call the bull nose, is gonna be much broader than x squared. So it's gonna look almost like this picture, much broader. Whereas x squared is going to be a little bit more pointish. Okay, so x to the 8th, x to the 10th, x to the 12th, they all have what we call end behavior that looks like x squared. In other words, as you go deeper negative, you go higher positive. As you go higher positive, you go higher positive as x increases. Okay, so, and then the same thing happens with the odd functions. So if you had x cubed, x to the third power, okay, x to the third power is an odd function. Notice the exponent, the lead exponent. We call this the degree of the polynomial. The degree is the highest exponent on x. And if you've written it in standard form, that's always the first term in your polynomial. So this is a third degree. If you had x to the fifth might look like this. And there's a little bump in here, a little bump where it goes up and down again, okay? Y equals x to the fifth. Odd function, fifth degree. Odd function, third degree. Even function, fourth degree. Even function, second degree. Okay? Notice the end behavior of all these, the fifth, the seventh, is going to be like x to the third. So there's going to be questions about all of this on this assignment today. So let me go ahead and show you a couple of your questions that you're asked on Alex and get you on your way. Okay, so, and these notes have been posted on Google Classroom for you, along with a couple examples. Okay, and let's do this. Let's start the assignment. Okay, so the first couple are just going to ask, is this odd or even? or neither. So, sorry, I just can't seem to get it in position. So this function here is, it's not x to the third, it's actually y equals negative x to the third. So I'm trying to remember, do I put this in parentheses? Yeah. It actually doesn't matter in this case because this doesn't matter which axis you flip x to the third over, it's going to be in the same place. So this is an odd function because it's symmetric about the origin. F of x equals, pardon me, negative f of x equals f of negative x. So we're going to call this one odd. This one here, symmetry about the y-axis, even. This one here, fifth degree polynomial, odd number. I'm not sure what all this is going to do to it. This is either odd or neither, and I'm just going to test it out, and then we'll let Alex tell us. I'm going to test it out as odd. And this one here, I'm going to test out as neither, because I'm just logically trying to see what Alex is asking, but they have an odd exponent and an even exponent. So let's test it. Fingers crossed. Wow, Mr. D. Now I'm telling you, I knew the first two, but I didn't know the second two. Here's how I did the second two. This and this are both odd exponents. That's why I said odd. This is odd and this is even. That's why I said neither. Okay, because this is going to give it some place where it's got a thing that looks like x squared, and this is going to give it a place where it looks like x cubed, which is going to throw it off, in my humble opinion. So let's see what Alex says. Explanation. Okay. More about even functions. Note the following. Some functions are neither. The only function that is both even and odd is the zero function. F of x equals 0 for all x's. Okay. In all other cases, if a function is even, then it cannot be odd. Okay, which is what I was thinking about this one. If it's even, it cannot also be odd. Okay. Yeah, see, g is a polynomial function. Each of its terms has an odd exponent. H is a polynomial function with both even and odd exponents. Okay, so h is neither odd nor even. Okay, so let's return to the question. And let's look at the next kind of question here on number 4. We're going to find all the real zeros. Now this is fun. Okay, all the real zeros. In other words, we have to get all the factors and solve it. Okay, so not as hard as it may sound. Okay, so 4x equals 0. So x equals 0. That's one of the zeros. X minus 9 squared equals 0. So remember, this is the difference of two squares. Is that going to matter for us? No. Let's just solve this. Take the square root of both sides. X minus 9 equals the square root of 0, 0. So x minus 9 equals 0. So x equals 9. And we would say, someday Mr. Gould's going to tell you, we would say this 0 has multiplicity 2. Multiplicity 2. In other words, this one right here is going to touch the x-axis, whereas this one right here is going to go through the x-axis. Now, the next one, x minus 5 equals 0 squared. So take the square root of both sides, right? So x minus 5 equals 0. So x equals 5. Again, multiplicity 2. Again. Okay, so if I was going to try and graph this, I could, I could do a good job at knowing the zeros here. X equals 0 is a through. Now it's got a 2, 4, 5. This is a 5th degree polynomial. If you multiplied these all out, you would get the highest power on x to be a 5. Okay? So it's 5th degree, which means it's going to look something like x cubed. And it's got this 0 coming through at 0. And it's also got 1 at 5 and 1 at 9, but these simply touch. And so here is what this is going to look like, this graph. See, there's a 0 that touches, multiplicity 2, that touches, multiplicity 2, that goes through, multiplicity 1. There's just x to the first power. And that's a 5th degree. So let me put them in and prove it, I guess, huh? So I have to put 0, 5, 9. 0, 5, 9. Check, please. Correct. Good job, Mr. D. Well, thank you. Let's get you to finding zeros, finding a polynomial given the zeros. Okay, number 7, 6. Find a polynomial with these zeros. Okay, so that means when you solved something, you got 2 as an answer. 4th degree, that means x to the 4th, something x to the 4th is going to be in there. Okay? That means that since you have 4 zeros, none of them are multiplicity 2, which means that, what did I solve to get negative 2 as an answer? X plus 5. Pardon me, x plus 2. I'm getting ahead of myself. What about this one? Just x. What about this one? X minus 5. What about this one? X plus 7. There is a 4th degree polynomial. Now, I don't know if it wants me to multiply it all out, so here's what I'm going to do for you. I'm going to save you leave your answer in factored form. Okay, so now we know. So we're just going to put it in just like this. So x times x plus 2 times x minus 5 times x plus 7. Correct. Yay. See, that wasn't very hard. Okay? And you're saying, Mr. D, what did you do? I didn't see it. Or you're saying, oh, that's too easy. Why is he taking so long? And he's going to show us again? Yeah, he is. Something equaled negative 2. X plus 2 equals 0, right? Subtract 2 from both sides. X equals negative 2. That's why that's the factor. X plus 2. 0. That means it's just x. It's just x. So there's no plus or minus in here. It's just x equals 0. It's already solved. Okay? So x minus 5 equals 0. So add 5 to both sides. X plus 7 equals 0. So subtract 7 from both sides. And you're going to get these. Here. That equals 0. That equals 0. That equals 0. That equals 0. And solve it. And that's where you got those numbers. So we're just going kind of backwards. Okay? So, let's see. There are a couple more problem types. Let's see. Determining the end behavior. And then matching graphs. Let's do it. Determining the end behavior. Number 9. Choose the end behavior of the graph for each polynomial function. Okay, so since this is a negative, that's flipped it over the x-axis. Okay? So it's something like to the third, but now it's flipped. So it's like this. So as x, and it's the fifth, so it's odd, so that's why these end behaviors are. So falls to the left and rises to the right. Falls to the left, right, no. Rises to the left and falls to the right. Yes. Okay. This one's to the fourth power, so it's going to look like x squared. It has a negative in front of it, so it's flipped over the x-axis. So, falls to the left and rises to the right? No. Rises to the left and no, because it's going to go down to the left and down to the right. It's flipped over the x-axis. Okay? So, we'll put that one. Then here we go. X to the first times x to the first times x to the second is x to the fourth. Remember when we used to add exponents in the 8th grade? Never thought you'd be doing that again, huh? So, and this one's positive, so it's going to rise to the left and it's going to rise to the right. X cubed, x squared minus 6x. So end behavior is like x cubed. So it could be C, but we're going to look at the zeros. Then g of x at -1 and at -3. It's just touching. And it's flipped over. Looks like this one, -1 and -3, just touching. Just touching, because these are multiplicity 2. See, it's the squared roots, the squared roots. So, let's just do it. Sucks to get it wrong. You're the teacher. So, x times x squared minus x minus 6 x times, how would you do this, Mr. D? Now let's factor. Factor the x out. Now x squared minus x minus 6. So this would be x minus 3 times x plus 2. Negative 3x, positive 2x gives you negative x, gives you negative 6. So you have a 0 at 0, and these are all multiplicity 1s, okay? And you have a 0 at -2 and at positive 3. So it's going to look like x cubed, has a 0 at -2 and at positive 3, and at 0. So This isn't it because this is just touching here. That would be a multiplicity 2. And it's not. Okay? This isn't it because this is reflected over the y-axis. Okay? What about here? Let's see. We go through at -2. We go through at 0. And we go through at 3. This one is E. Now, I hope I get one right. Correct. Yay. All right, you're on your own. Have fun with this assignment and contact me if you need help.